All right, so learning target we are looking at here says, I can analyze the rate of change between an input and output values to determine if a function is linear or nonlinear. So we've got a lot of words going on there. We're focusing on the words linear and nonlinear, and we're focusing on rate of change. And that rate of change is going to tell us whether the table is linear or nonlinear. And it's also, we're working with the inputs and outputs, and those are just our x and y usually. A lot of times they're not our x or y. If they might be n, or they might be stand for c for cost, but in general, we substitute an x and y in those places. All right, so rate of change. So what we're looking for is change of y over change of x, and we're looking for a consistent same unit rate every time. So if I look at this is going up by 2. That's my y, so that's going up by 2. And this is going up by 1. This is already in unit rate form. It's 2 over 1, so I don't need to do any simplifying there. Now I just need to check if each other rate of change is 2 over 1 as well. This is going up by 4. And this, I'm sorry, I already wrote it there. And this is going up by 2. And I would have just wrote it right there. So this is 4 for every 2. Then when the y is going up by 4, the x is going up by 2. And 4 over 2 is simplified down to 2 over 1. And 2 over 1 is the same thing as 2 over 1 here. So right now we're good. It's still linear. We need to check this last one. So is that going up by 6? So my change of y is 6 over the change of x is 3. 2 plus 3 gives me 5. And so that's 3. And 6 divided by 3 is 2 for every 1. And this unit rate, and this unit rate, and this unit rate are all the same. They all simplified down to the same, so we're going to say this is a linear table. Okay? I could make an equation of that, and I could see here that there's my y-intercept. So I'm going beyond just whether it's linear here. And I would say y equals 12 plus 2x. 2 being the rate of change and 12 being that y-intercept there. All right, moving on, looking at the next one. Same thing, is it linear or nonlinear? We're going to be looking at rates of change between the inputs and the outputs. So I'm going to set that up, change of y over change of x. And I'm going to say here my change of y here is plus 3. 3 plus 3 gives me 6. So then I'm going to put 3 over change of x is plus 1. This is already in unit rate form. I need all of them to end up being 3 over 1 in order for it to be linear. So I've got this, and I've got 6 to 9, that is plus 3. And this is going up by plus 2. 1 plus 2 gives me 3. So 3 over 2 is not equivalent to 3 over 1. If I were to simplify this down, I would end up with 1.5 for every 1. And 1.5 and 3 are different numbers, so therefore that's making it nonlinear. We're in the unit rate form with it over 1, and it's nonlinear. All right. So now you're going to work on your owns below, and you're going to be doing that same thing. You're going to be looking at each one of these tables, and are they linear or nonlinear? You're going to be modeling what we have here.